All right. So can everybody hear me? All right. So I've been playing around a bit. It's probably gonna take me the weekend to get like super sharp. But I'm trying. So all right. So what we're gonna go over today is we're gonna try to go over some networking. Um, and I see somebody talking about the OSI model real clear. So that's exactly what we're gonna go over today. Uh, and and we're gonna do some stuff that gonna lay some foundation. Um, and we're also gonna do some hardcore stuff. My dogs just started to get active when I started talking. Uh, so, all right. But the dogs, we're a dog friendly show. All right. So, let me view here. Let me see if I can pull up the slide pane right here. All right, that's gonna help me out. All right. So, hold on a second here. Let me try to make this thing bigger. Struggling with dang slides. Hold on a second here. What I'm gonna try to do is I'm just gonna open up a text editor because that's easy. And hopefully I can make the view big on the text editor. Man, I'm sucking. Alright, let me just open this up. Alright, so I'm about to open up something. I'm about to like I'm trying to write as much as possible. I'm about to do like a brain dump on the OSI model. And what I'm gonna do is I'm gonna cover all the stuff. So some people that are new to security and new to internet working are gonna get like people are new is gonna get this might be a lot of stuff, but I gotta cover it and I want to cover it pretty well. So I want to try to make sure that I got a cursor big enough so everybody can see it. So we talked about the OSI model before, and what we said before about the OSI model is the OSI model. We and I see people getting super active. Is like it's a 7-layer model. Is created so all systems can interact with each other. Hold on a second. I gotta kick my dogs out the room because they're actually being annoying. Hold on a second. Hey, Bam, get out. All right. I have to let one dog go out. I'm making it big because some people were complaining about it not being big enough. So, and I understand. Let me enter our page. I'm trying to get the people what they need. So basically, the OSI model is 7 layers, and what we talked about is we talked about application and all that stuff. Let me start off with physical layer, right? And so, what the physical layer. And that is huge, but that's okay though. The physical layer is layer 1 of the OSI model, and what we normally do is when we talk about the OSI model, we do it backwards. We do it backwards. I mean, we actually stack them on top of each other from like here. So what this is and I'm gonna go through this because this is super important because we were going real deep and going into Wireshark, and some people may have been confused. So the reason why I'm using freaking text editor is because all these Ubuntu tools I'm not used to them, so instead of being annoyed, I just rather just type into a document. All right, so what we're gonna do here is physical layer. So physical layer, we said electronics, right? Electronical or radio waves. We say light rays because it could be a red light, it could be fiber optics. So those are the three main ways. It's either some kind of cable, some kind of radio wave, or some kind of light transfer. So typically when we're talking about on the wire, we're talking about we're talking about that's exactly what it is. This is pretty much when I talk about the physical layer, it's the physical specifications. You got all kind of physical specifications on the objectives for Network Plus, and then the other thing, what they're talking about here, there's all these different specifications, 802 dot this, 802 dot that, fiber specifications. There's all these specifications, but they're physical layer, and this includes satellite communications. This includes like how if you have a cell phone, how this communicates to the internet, because it does it over two different things. It does it over frequency to the antenna, and also does it through your Wi-Fi on your local network. So all that physical stuff, and there's Bambi trying to break back in. All the physical stuff related to communicating to the internet, that's physical layer. That's layer 1. Layer 2. Dang, I suck at this thing. Compute on this freaking stuff. Dang, I cannot get a break on this today. Hold on a second. Alright, cool. So layer 2, data link. You might see it spelled data link, or just like I just spelled it. Like, now what this is frames. Frames on how frames are, as we saw in Wireshark the other day, those frames, or you can say it, some people compare it to like a bus, like how you can get so much stuff into a frame, into like one of the, if you take a rail car and you have the different little rail cars on it, just imagine a frame like that. And the frame, those are, and typically most of the time you're using Ethernet frames. You're using some kind of Ethernet specification. And so, and what that does, it handles local communications. Well, sometimes things work, sometimes it don't work. Local communications. Now, I told people that locally, like when I was growing up, I had a nickname. My nickname was Butch. And some people were calling me Butch in here, which is hilarious. I love it. But local communications by MAC address, right? And so that MAC address is it stands for Media Access Control. And that's an address, and some people call it a burnt-in address. BIA, a burnt-in address. Now, every manufacturer, so you can change this through software, but by default, it's burnt into the MAC address. You can spoof a MAC address. You can always do those crazy stuff, but for the most part, a MAC address is a burnt-in address. So, and somebody just said logical link control. That's actually true. LLC, logical link control. That means we need to control how people talk on that local link, and how the old school way of doing this, and there's still some of this today. There was this thing called carrier sensing multiple access. And I'm going to type this out. I think this is sensing multiple access. Now, I might get some of the terms a little bit off, but I'm going straight from the dome. Now, what this means, this term means that there's multiple machines on the network, and they can all sense a carrier. That means, hey, cool, I'm connected to the Wi-Fi. So when you connect to the Wi-Fi, when you have all the bars or whatever on your computer or on your cell phone, when it shows you have connection to Wi-Fi, that means you're sensing the carrier, right? Now, all machines can't talk at the same time. That's why when a bunch of machines get on that same network, the traffic slows down because you're all competing for that access. So multiple access, you're competing for bandwidth. Now, when somebody starts streaming, funny story, my son is trying to get his game on. He just woke up. They're on quarantine, so that dude woke up at like 5 today. What a life. So he's in there. He want to get his game on. He's like, Dad, you streaming tonight? And he's like, oh, that sucks. And so, but basically, multiple access, you're going to have this thing called collisions, right? And there was this thing called collision detection back in the day, was used a lot. And so basically, if at a layer 2 level, if you both transmit at the same time, two machines can tell that, oh snap, we're sending at the same time. So there's also a thing called collision avoidance as well. That means we're going to avoid getting these collisions. Now, all this stuff that I'm talking about here, big picture, is Ethernet. And that's how, and most of the specifications follow this stuff as well. So it's for local access. And what's important about this is to remember is we talked about this carrier sensing multiple access, and there's pictures and stuff that you can draw on the thing. But essentially, the specification, whether it's Wi-Fi or whether it's you have Ethernet running throughout your house, you have cables, you have fiber coming to your door. All those things are physical access. Physical access to medium. The data link layer provides a logical way so everybody can communicate on that medium, right? So that actually has to do with your local area network big time. Remember the analogy: too many people streaming on a local network. That's going to always create problems. So that's where layer 2 handles that. Layer 3 is a network layer, and network layer handles addressing. So global, I would say global addressing, because if you need to get to Google or something like that, we talked about this before. You're going to do a DNS resolution. That stands for domain name servers, and you're going to get an IP address, and you're going to go to that IP address to get whatever resource that you want it. So global addressing, and those are called IP addresses. And that IP address can get you from your local network. And then there's this thing called NAT that we'll talk about. And let's talk about it now. It stands for Network Address Translation. Your machine on your local network will be converted to a globally, what we call routable address. So if you type in what's my IP in Google, it'll tell you your local IP address. So what you can do, what that means is that when you're on the internet, you're talking, your internet service provider is acting as a global representation for your network internally. So when you go out to the internet, you have a different address that's globally routable. But on the inside of your network, what you have Layer 2 tunneling protocol, I see somebody talking about it. I think that term's misleading, to be honest with you. Layer 2 tunneling protocol goes over IP, so that's an application to me. But the NAT, network address translation, that's how you communicate to anything on the internet. Translation. Now, I know you know some of these terms before. I'm going over all these terms because I want to make sure that we're all on the same page. Now, Jake wants out. I'm going to have to lock him out now. All right, don't come back in, booger. All right. So global addressing, this is kind of like the post office delivering something. It's a global network of routers that are across the net. So let's do this too, routers. So routers reside at the layer 3, and at this layer right now we do switches. Switches usually have plugs in them, but in actuality, layer 2, anything that handles layer 2. So funny enough, and this may be controversial to some people, your Wi-Fi access point gives you physical access, and it handles the logical link control as well. So to get on the Wi-Fi. So what I'm saying is, if you have the bars on Wi-Fi, what that means is you're connected to your local access point. That does not mean that you can communicate throughout the world, though. Your Wi-Fi access point. This can also be a WAP too. I'm going to just say a WAP. That acts as a router, and firewalls begin to essentially work at this level from a security standpoint. You can also, at this point here, we can start talking about security concepts too. You can actually do you can do MAC you can do access control here. You can do MAC filtering here. And you can control who gets on your router, or you can control who can plug into the thing. So this is a security term. This is a security mechanism right here. Here, a wireless access point can act as a firewall. Now, only thing a firewall does by default, let's talk about routers. What routers do? Routers, and you might have your definitions. I'm just gonna go on over this stuff. What routers do is they route traffic for sure, and they keep routing tables. Those routing tables are maintained by routing protocols. Routing protocols is how the routers talk to each other. You also have these things called routed protocols, funny enough. But routed protocols, the only one that we use mainly is IP. IP is a routed protocol. The routers change information, how to communicate with each other. A routed protocol is IP, and that's pretty much what everybody uses. You may see discussions of other things, but from a global routing perspective, IP is the boss. So routing protocols, there's a lot of those. Routing protocols. Let me type this out. Routing protocols. Now there's a couple, but the most there's one that's called. You can look this up. I don't know how important this is right now, but RIP, it stands for Routing Information Protocol. OSPF is a open source protocol, but the one that's used the most by everybody on the internet uses this thing called BGP, and that stands for Border Gateway Protocol. Now, the only thing about these routing protocols is that this is how the routers exchange information. So router A and router B exchange information with each other. All right, so I mentioned a term earlier. When I say MAC filtering, what I'm talking about is if you have a MAC address, you can actually find out the MAC address on your machine, and you set on your MAC address filtering. Two devices do this. It has nothing to do with Wireshark. There's Wireshark filters, but the filters are on a router or switch. You may hear the term. You're going to hear the term. A switch is something you typically find in the network closet. That's the easiest way to understand a switch. It's the thing that you plug in a bunch of cables in your Wi-Fi closets. I mean, in your telecommunications closets. Heck, I go to you can see these anywhere at stores, at your office, and they look like the back of your router at home, pretty much. So either one of these can do it. I guarantee you, if you go into the configuration of your home access point right now, you could probably do some MAC filtering. To do MAC address filtering, to do MAC address filtering, you need to know the MAC address, the burnt address of your machine. And I already see somebody said you can spoof these. You absolutely can spoof them, but from an external perspective, you almost have to know what it is. So basically, most security controls can be circumvented, right? But that's why we do defense in depth. We do multiple different layers of things. So right now, what we talked about, and this is a lot. So we talked about physical, we talked about networking, routed protocols. The only one that's popular right now is IP. Routing protocols is used to share information. I'm highlighting that. MAC address filtering is done by the router or switch. Network address translation is important because what that does is it turns your private internal IP address to a globally routable address. I'm experimenting with my whiteboard. I got a whiteboard right here beside me. So I'm gonna try to set up the whiteboard so I can actually whiteboard some of these concepts and go through them. All right. Now, what I really appreciate, and I want to give a shout out to everybody participating in the in the chat over there on Discord. The Discord chat is awesome. People are really going in. I love it. All right, so and some of these things you've already covered in terms. I'm just going to give you the Marcus Carey explanation of some of these things, because some people tell me sometimes when I explain it makes more sense. We talked about the next layer. The next layer is layer 4, and that's the transport layer. Two things reside at the transport layer, and those are TCP and UDP. The key thing is connection orientated here. UDP is connectionless. And And stay tuned, everybody. If you know what I'm gonna do is I actually downloaded Snort and installed it today, and I'm gonna walk through Snort and show you what this all means in an intrusion detection system. So, um, there you have that. So basically, we said the big thing about TCP is there's a three-way handshake. That's SYN, ACK, and then that's the three-way handshake. This one is best effort, is what we call it. Five. And I'm going over this stuff because being able to troubleshoot and do diagnostics and understand this is so critical. So you might think I'm beating a dead horse, and I am, but we're gonna beat this horse all the way into the ground. We said transport, Nexus session. And y'all know, if y'all been following me, y'all know what I think about session. I'm waiting for it in the chat. It's very controversial. Presentation. My stretch on presentation. Presentation is kind of a stretch too, by the way, but I'll give it a little bit of, deference. So I'm just gonna say, people always told me that it was like matching up protocols and like PNG, stuff like that. Other people might have different things, but I'm not gonna hate on presentation as much because it's kind of an understandable thing. But application certainly does exist. In application, we're talking about DNS, HTTP, HTTPS, etc., etc. So all those protocols. Now, why this is super important is when we're gonna look at a couple of things here, and we're gonna be cracking open Snort, and we're gonna go through look at Snort rules, and see how they actually work. All right, network plus test. Somebody says this assumes the responsibility for managing network connections between applications. I've heard remote procedure call, but I'm telling you, whoever wrote that test has never ran a Wireshark before. All right, I'm gonna take a quick break. I'm gonna take a 5-minute break, and I'll be right back. Hey, did anybody find the session layer while I was gone? Like actually in a packet? All right. So yeah. So for any test you're taking, learn whatever they say session layer is, right? But I would say like the reason why the whole session layer thing and I'm just I joke about it is because remember this whole thing came from a the the application layer. So the session SPA, that whole session presentation and application was just one layer back in the day, right? So that's why, and maybe they had some kind of plans or something to do it, but that's what it is. All right, so we're gonna keep it moving. Now, hopefully the OSI model again, it was made by vendors essentially to be able to make sure that if they made different network material, that it would be they will all be compatible. So that's how we all got phones, we all have computers, we have all this stuff now that it just all works together. And it's because that there's some kind of standard. Again, there was kind of a war back then. Refresh if it's fuzzy or something like that. There was a war going on where Apple came out with their own little protocol called Apple Talk. There was there was NetWare. They had this thing called IPX back in the day. And Novell, should I say, Novell NetWare was their like network suite. So there was several different competitors, but at the end of the day, Microsoft had their own dang protocols and all that stuff too. But at the end of the day, when everybody started connecting to the internet and all the colleges got online, the only way to communicate between those long haul communications was IP. And eventually everybody put an IP stack on. So Apple put an IP stack on, Unix put an IP stack on, Macs, if you have a Mac, whatever, everybody's speaking IP now. And that's super important to understand. All right, so I'm gonna try to go over here. Hopefully by the end of this hopefully by the end of this 8 weeks, I understand what I'm doing on this Ubuntu. I'm usually a Macintosh user, but I don't want any. I'm trying to separate my Mac between what I'm doing here, so that's why I'm using a virtual machine. All right, so we went over a bunch of Wireshark. What I'm gonna do here is I'm going to talk about. We talked about how these different protocols and stuff work. What I really want to do, man, I wish I had a dang whiteboard in front of y'all right now. So I'll be getting busy. All right, so I downloaded Snort. All right, we talked about all kind of different things. We talked about routers, switches, and all those different things. Excuse me. Let me just go here. Let me go to Google and just show you what a couple of things are, just in case you don't know. So switch. I'm gonna type in network switch. So we're all on the same page. This is kind of like what a network switch looks like. These kind of things. So in bit closets, look at that, 16,000 for that. God dang. This is a big switch, big catalyst switch. Found these in network closets and stuff. So basically you plug them in and go. Most people know what those are. Most people on the back of your internet, you probably have a couple of plugs for that stuff. So if I say network switch, I'm going to say network closet. And network closets typically look like this. This is a good picture of that. Network closets, some of them are very messy, but a bunch of dang wires. So let's look at this real quick. So these wires, this is physical layer. So when you're troubleshooting, what you want to do is you want to go through all these layers when it comes to. Dang, can I blow this thing up? Dang, it's not giving me a big picture. So the yellow cables, I'm trying to show yellow cables. People get pissed at me because I can't show my cursor. Hey, I looked it up. I can't figure it out. I think it's a problem with Macintosh and VMware. So the yellow cables coming out the switch on the left. The switch is the black box on the left. Let me see if I can highlight that. I'm trying to highlight it real quick for y'all to see. That's what I'm talking about. The yellow cables coming out of this thing and in it, that's physical layer. And even the ports that you plug it into are physical layer. And the reason why I'm talking about this is because sometimes the wires go bad. Sometimes the power goes out. That's a physical layer issue, right? If the power is not going to this joker, then you're not communicating with nobody. If somebody didn't crimp the cable right, you ain't communicating with nobody. If there's, and this happens all the time, no joke. I've been in geographical locations where when it rained, it caused power issues and it caused network connectivity issues. And sometimes even like when it rains heavy, you will see network degradation. Many times that means that somebody took a power cut or something flooded somewhere. It happens all the time. So, for real. So basically, you know, I have a really good story about this, right? So my buddy, he was working at a government agency. What they did, and it was kind of like a big rack like this. They had some servers in it, and all his servers went down, right? And the servers went down, and he couldn't figure out, you know, he's trying to get access to them. What happened was, he went down in the basement, and they were doing maintenance on the racks. And what the construction people did that was doing maintenance downstairs is they took wrapped like plastic wrapping, like saran wrap, and they wrapped the whole closet so it wouldn't get wet if it dripped above, and so it caused the servers to overheat, and that heat caused them to go down. So here's the deal: physical layer. Make sure that the physical layer is good, and that's why you monitor stuff like heat, memory utilization, all those different things, because those are, in some cases, those can be physical type situations where your network goes down. Now, old school networking, old school security, we talk about three things. We talk about confidentiality, integrity, and availability. Now, funny enough, I looked at on this chart, and I don't see that nowhere. I didn't see that on Security Plus. So this is something you need to remember. Good day, Marcus. Can you get to work? Confidentiality. This is really hard for a Texan to spell. All right. Now these three things here are the golden tenets to cybersecurity. People call it the CIA triad. I heard some people got pissed off because they said it was the CIA. Hey, I don't like the CIA either. So, the confidentiality, integrity, and availability. Hey, if anybody on CIA on here, I still love y'all. All right. So what I'm talking about here, though, is those are the tenets. So basically, you have to have availability, right? Is it under there? About the exam on there? I didn't even see it. I tried to look for it. All right. Confidentiality. We want to keep everything secret that should be secret. I want to protect medical records. I want to protect my banking information, right? Integrity. I want to make sure that all the numbers in my bank account are right and the decimal don't get messed up. I want to make sure that my medical record is not tampered with, and somehow somebody puts in the wrong prescription, or say I need the wrong leg cut off or something like that, right? So that's it. So that's how basically everything I talk about is centered on this somehow. And there's actually an opposite of the CI triad, and this is going to be a bonus for some of y'all. This is not on the test. This is Marcus J. Carey here. So, confidentiality, the opposite of this is disclosure. And I actually stole this from my buddy a long time ago. Disclosure, integrity, destruction. So basically, the opposite of the CI triad is the DDD triad, triple D, 3D triad, right? So what happens here is that confidentiality, the opposite of confidentiality is disclosure. So you think of this from a hacker perspective or a bad security perspective. If you make a disclosure, and that's an unauthorized disclosure, of course, that's terrible. Integrity, meaning that either the data is good or the integrity is destroyed. Now, in many cases, ransomware is a good example of this. Somebody said, "Dad." I like triple D, but I like that though. Somebody said disclosure, alteration, and denial. I don't have a problem with that. Somebody said alteration. I like that. Even though that sounds kind of like HGTV to me a little bit. But hey, I'm a big fan of Fixer Upper. I'm from Waco, Texas. So, alteration. I like that. So, on these, that's what if you're an attacker, you're trying to do one of these different things. Right? And you're trying to destroy data, right? You're trying to, if you're a bad person, and you're trying to deny that data. You know what's crazy? You know what I love about ransomware from a ideology, from a how you think about it? It's actually one of the only things that affects confidentiality, because if somebody gets access and ransomware their whole network, they have access to all your data. And some of these ransomware people are leaking data if you don't pay. They also mess up the integrity of your data, right? And they also mess up they also deny you access to the data too, or your systems or whatever. So that's what it is. So I really like thinking of this like that. All right. So on that, that's like super important. So if you're trying to be a cybersecurity professional, we're trying to provide for the CIA thing. So remember that. Somebody said it might be on the test. I didn't see it. I tried to do a control find. I couldn't find it. But then again, I don't know what I'm doing with computers. So, all right. Let's go on to. I'm gonna go over to the dang PDF. Which one is this? Oh, actually, this is Snort. This is what I've been playing around with IDSs. So I downloaded the Snort installation guide. So I'm crazy. I install stuff. There's a couple of distros that you should be aware of. If you don't like installing stuff, you should be familiar with Kali Linux. It's Kali. A lot of people probably use it in here. And there's a security version, the security thing called Security Onion, that actually has a lot of things on there as well. But me, I'm crazy. I'm old-fashioned. So what I've been doing today is playing around with Snort. And what I want to do is show you some Snort stuff. So I'm going to do cat local rules here. And so there's a couple of different rules that's already is built in here. And I actually, I finished installing Snort at the end of the day today, so I didn't have a lot of time on this. But this is something we're going to be paying a lot of attention to. So, what's interesting here is a couple of things. I'm going to walk you through this. Let me see if I can blow this up for y'all. I think everybody can probably see this, right? So what's cool about this is that if you look in here, a Snort, dang it, I brought it up on here. Let's Snort. This is the Snort little logo. I love this logo. It's old school. Hasn't changed in all these years. But what Snort does is it just like Wireshark in a sense that it captures stuff on the wire, and you can actually do regular expressions and all kind of other crazy things. They have like some really powerful regular expressions, and you can search for different things, and they even have application centric detection capabilities too. What's important about this, right, is right here, what you can do is you can actually put rules on this to alert in certain situations. So right here it says alert, and it's TCP. So what this means is Snort will alert on a three-way handshake, right? So hopefully y'all doing okay out there, right? So this is super important because what I've been trying to beat home from day one is everything that I'm telling y'all before and drilling on TCP. You're probably like, why is he talking about TCP all the dang time? This is why. Because if you understand what TCP is, you're going to inherently know, oh, there must be a three-way handshake here for this, in some cases, for this rule to even fire. Right? This is a IDS rule. I'm going to go into more IDS rules later. And you're going to be able to write your own IDS rules at the end of this thing. Right? So remember I said when I was looking through stuff manually and doing all these find for place and all the garbage, right? So this actually can let you know things like that automatically. It does it for you, and it can do it in high volume. You can put an intrusion detection system. This is called IDS, right? And so what this is intrusion. Whoa, I always spell intrusion wrong. Detection system. And what we're using here is Snort. It's available on snort.org. That's the website. You can download it. And if you put this is pretty cool. It's a little, I can just enter. It's not going to run that command. It's not going to run it because I did a comment here with the pound. So intrusion detection systems is what we're talking about here. All right. How an intrusion detection system works is it works at several different layers. It works at, as you see here, it can work at the network level because this is network stuff. From any network, and you can put a mask here to any, you can put a mask here. So you can have collections of networks here. So you can say, hey, if there's a TCP connection from this network to this network, and this is what this little arrow function does. This says if it's from any network to any other network, right? And it matches this Facebook ID, I'm gonna know. Maybe your network has a dang policy where nobody should go to social media, right? Oh, you're right. Somebody pointed this out. My bad. So this is any IP. Thanks for the chat. And there's actually ports as well. So the port would be the TCP port. So for this, it would typically could be like 443. It's an HTTP port, and that's going to all be in the configuration. And so any IP address, any port. That's what this means. So this is the TCP port, and this is going to be any destination and any destination port. That's what that means. Thanks for saying that in the chat. So typically, what you can find here is you can find home network, right? And there's going to be like HTTP ports, or you can actually put a port on there if you want to. Second thing here is it says ICMP. ICMP is another protocol. That protocol is listed on Network Plus for sure. ICMP is like pinging. So basically, this one is going to alert anytime somebody pings. So with that being said, we can also go. Let me actually. There's actually other rules. And this should probably work. I have to enter my password real quick. So when the IDS runs, what it's doing here, and you're gonna see here, I want to go up slowly. So what's happening on your network, what you'll do is you'll run this and you'll put this on a machine and it's always running if y'all not familiar. You can put this on a virtual machine or you can put it on a piece of hardware. And SourceFire is the person that made this originally, or this dude named Marty Resch. So Marty is actually like an ex-Air Force guy. I know him. He worked. He built a company and then he sold it to Cisco. So Cisco Systems actually owns this technology, and this is an open source product. What's cool about this is you can go in here and there's all these different rules that's going on here. You can see it loaded 508 rules. And what's cool about this is these rules operate on different things. As you see here, these are community rules that I loaded, and so plus those three you saw in that little file. There's one ICMP rule in here. You normally wouldn't run that ICMP rule because anytime somebody ping is going to do it. But what's cool about this is like we already got the alert, and this is what a snort alert. This is what a snort alert looks like. And it's probably because I'm on a virtual machine, so it's seeing stuff. So this is what most logs look like. And what I'm going to do is I'm going to show you some more logs. So this log, this file right here, as you see, it is saying this is an ARP spoof, and it has another one. So one of the rules, this is triggering one of our rules. The rules are down here, and I wonder why that dang Intrusion don't work. I'm gonna have to practice on the weekend. What you can do here is you can also say, I want to ping google.com. And you see that's pinging google.com, right? And we know that one of the rules was any ICMP. Let me stop this. Now, I shouldn't have had to stop it, but I'm on a virtual machine. I don't know what's going on. It says ICMP traffic detected, and this is the rule that we saw in those local rules. So, now with Wireshark, I would have had to go in there and I would have to do a find, and then I would have to put in port, and I would have to put in ICMP, and I would have to do that manually, right? So what's cool about this is that the basics always matter, right? We know ICMP. ICMP is a networking communication protocol. Is really built so routers can talk to each other. That's what the whole point of it is. Now you can use ping tool. Ping stands for Packet Internet Roper. So ping can be used by end user, but the real reason why it exists, somebody can, I need to figure out my dang cursor thing because it's driving me nuts too. So this rule right here, and I see somebody gave me some advice. They said I can show a pointer while it's in. I wonder what application I need to do that in. But right here, this rule fired off because the rule that I showed y'all a little bit ago. Where's that dang local rule at? So when I did this cat local rules, see right here, the signature ID. This is what SID stands for. I'll bring this up. This is the rule that kept on firing when I did the ping. So this stands for signature ID. And the signature ID for this right here is the one that was tripping. So, and I can also specify the text too, the text. So this rule would never really exist on the network. I mean, you never know. You might have a reason why you want to test for somebody pinging. But didn't it show me? Yeah, it showed me statistics. But this is the one that was tripping, right? Tripping as in, not tripping like I be tripping, but tripping as in it was giving you an alert. Yeah, and so what's cool about this, I downloaded this is pretty cool. So basically this was a guide on installing Snort on Ubuntu with Splunk as the SIM. So Splunk absolutely, Snort is what we're using here. Snort again is the IDS. So what Snort allows you to do is export those. You can export those into a log manager like Splunk or Elasticsearch or whatever you're using to search. One of the things I'm going to do is I'm going to build a fake SIM. I'm coding on some stuff on the side to work in the class. So you can definitely do a couple of different exports. This is kind of like syslog format. What's important, I want y'all to understand what logs look like. So say if this was some kind of bad thing that happened, really, the couple of things you need to know is this is a timestamp here. And this timestamp, funny enough, is in local time, which you never want to do. You never want to put your machine should always log on Universal or Zulu time, and you always want to make sure you set that time up on all your machines on your network, so when you go back, you can go back and you can look to see, and you can synchronize times in your devices, because this would be a train wreck if other machines were in different time zones on my same network. So definitely, if you're working for a big company, everybody should have this stuff going. All right, so what I'm going to do real quick is I'm going to take a 5-minute break. Security Onion, I see a question there. Security Onion is another pre-configured Linux operating distribution, and what they do is they configure tools like Snort and other things to run on it. So it's a great one. You can download it. It's a CD or DVD, and you can install it. I haven't played with it in a while, but you can actually run it live. Last time I checked a long time ago, you can do it live, or you can install it. So Security Onion, definitely check it out. All right, I'm gonna take a 5-minute break here. Hey, I appreciate y'all, and thanks a lot for helping. Thanks a lot for being so responsive to your everybody in the chat. and on Discord. It's awesome. So somebody said configure login to use UTC. I think UTC is Universal Time Code. I believe that is Zulu time. I'm in the military, so I always say Zulu time. So somebody said, so use Snort instead of Wireshark. Yeah, I mean, so different applications. There's going to be chances. There's going to be like times where you can't respond and you don't have something like Snort. Hey, but what's cool? I'm going to show you. You can actually read the Snort files. You can actually do a PCAP, and I'll show you this, and you can run it to Snort. That's cool too. Yeah, funny enough, I was stationed in Scotland, so I remember the Zulu time being on the same time as Scotland. It was cool. All right, I'll be back in a second. All right, I'm back. So I'm gonna try to handle some questions real quick. Oh, okay. So the 3 tenets, or the tenets of cybersecurity in general. Um, so basically, the 3 tenets of cybersecurity are CIA. If you type in CIA triad, so what's crazy about this whole thing is, man, there's a lot of people trying to be good at, like, their online, their little optimization situation is good. All right, so is CIA triad on her? God dang. All right, so right here, man, I suck at computers. Hold on a second. Let me see if I can blow this up. All right. So basically, at the core of this thing right here. Whoa. This what I'm talking about right here. So everything we do should be known to tie back to this. Now, sometimes we do a bunch of crazy stuff in cybersecurity that has nothing to do with this, and I don't think we should be doing that. So in systems engineering, programming, all those different things, you have the CIA actually means something there. So I would say they're like confidentiality. So, you know, a lot of people were talking about Zoom being exploitable and stuff, and how you could get compromised. So if you're building software, you want to maintain these tenets as well, right? You want to build software that maintains the confidentiality, integrity, and availability of whoever the users are. If you're building systems, if you're building a healthcare system, you want to make sure that it has confidentiality, integrity, and availability. And so this is like, if you have a fuzzy view, refresh. Should. Yeah, so I think that what you have to be able to do is you have to break everything down to how is this secure from a insecure. It means it's confidential, integrity, and availability. Oh, I'm gonna go back to dang. I'm gonna go back to that snort in a second here. So just be patient. Is that right? Goddamn, I can't spell confidentiality. So, there was this thing, integrity, availability. There was this thing when I was at NSA. We had this thing at NSA called the Information Assessment Methodology. This is not on the test, but what I care more about y'all being beasts than the test, by the way, because some of y'all gonna take the test, some of y'all not, right? And it's called IAM. This should be freaking revived because why it's dope, and I'm gonna show you why it's dope real quick. So what it told you to do is it told you to, all right, if you had a patient record, right, what's the most important about that? We're going to do an assessment on this real quick. And this might take a little bit of time, right? But check this out. Is confidentiality most important? Is availability of that more important? Whoa. What the heck? Can I do that? Click. Oh crap, I can't spell. I'm glad y'all can see me talking to myself. This is so funny. This is how I'm in real life. All right, integrity. So basically, you look at whatever you're doing. What am I trying to protect, and apply apply this to it, right? So some may say confidentiality, and I was like, why confidentiality? And some people will say stuff like, well, it's private information. All right, cool. We're gonna keep it private, so we're gonna super duper encrypt it. But funny enough, I'm gonna tell you this is what's most important to me. That's super important that it's available, and then maybe this one is second most important, because you might want to make sure you need to make sure it's available, and then we want to keep it secret too. So what's funny though is like when people like, this is crazy. I'm finna go on a rant real quick. The Zoom vulnerability. People were talking about Zoom 0 days, and they didn't consider any of these things right here. Now, if you're a big organization, and don't look at it like that. Somebody said you don't want it available to everyone. Yeah, you want to make it available to the right people. And so when in the military, another thing, and working in the government and stuff, we talked about a need to know basis. It's kind of like a meme, right? Need to know. So basically, everything should be on a need to know basis, first of all. But if I'm a doctor, in order to treat a patient, I need to have their chart available, right? And I need to make sure that chart is, you know what I'm saying, that chart actually has to have the right data on it too. Because if I make it too much security, right? If I make it too secure, triple fold encryption, and I just made that up, all this crazy stuff on top of it, I have to use 15 badges to swipe it, you know what I'm saying? And I can't treat the patient. So it's super important when you're talking about securing something that you do an IAM. You do an IAM assessment. You look at the information, and then you evaluate what's the most important pieces of it. Now, maybe all of them mean something, but there's some data that it would matter. Some data, what's important, or some resources even, the availability is the only thing that matters. You know, and I would say the availability of a dang, test kit or something like that. Or dang, right now, mask, right? We need freaking mask. You know what I'm saying? So, the availability of the mask, like physically a mask, would be great. We don't care. Like, there's a mask all over the freaking place. People hiding them and stuff. We don't care about that. We care about if they're available or not. And we care if they're clean or not. So this is kind of like, I'm very simple. And so what I do is I like everything in my head. What I do is I was like, all right, boom. This is how you do it. You don't just say, oh, you can breach the confidentiality of it. There are some things I don't freaking care about. And there's probably stuff you don't care if people know. I don't care if y'all know my name's Butch. My nickname's Butch. So that's on no password guessing thing ever for me. So but anyway, so these things, you need to, like, if you can read a little bit about that. Somebody said there might be a NIST thing in there, but this is how you think about security. All right, let's go over to Snort. All right, so Snort tells you all kind of cool stuff. It tells you about ARP. ARP is address resolution protocol. It said it's a 12 ARP requests. It's all these these Ethernet frames, it's all ICMP, it's all IP addresses, it's all TCP, it's all UDP. Now, again, remember me telling y'all about evergreen, right? So, evergreen means that if you learn the stuff that we're talking about here and know how it applies to the real world, you're going to be a beast. Nobody can stop you. And like, there's a lot of people on your network right now, and maybe even the networks that we're traversing here, that have Snort installed. They're running this. In some devices, even if they don't run Snort, they're using Snort rules. So if you can go in there and run a dang Snort rule, you're good. All right, let me look at something else real quick. So what I want to try to do is I want to go in here and I want to show this other thing. So Snort has changed a little bit. When I was looking at this, actually my dogs sound vicious. I don't know if you can hear them barking. They're going bonkers. So when you start looking through these things, you can start figuring out what they're talking about. This is related to DNS. This is related to, I don't know off the top of my head, but you see these services in here and all these different things, and this is why it's important to know them and know what they do. This is FTP and FTP data. I was talking about how 20 and 21 are both used for FTP. So basically, you can go through here and you can start understanding these different things. And this is the configuration for the snort thing. You don't have to know this stuff right now, but what I'm saying is, like, this stuff is definitely accessible if you know the rules. So all these devices work the same. I see people talking about Zeek, Suricata, and Pro IDS. All these things work the same. Like, you learn one, and then you can pretty much you can pivot and learn others. Just like with programming, if you learn one language, you can actually program and then in different languages. So when we went through here, again, this is a long freaking command, but like I said, we're gonna get to it, and So the reason why you run this on your network is because it would be too hard for you to manually to do this. In security, we need to automate. Snort has been alive for about 20 some years probably. Now, all these devices and all these different firewalls and all these different things, they pretty much work the same way. They're sniffing traffic in some way, and they're providing you a service where Snort is optimized to do rule detection and things of that nature. And so, and the easiest this, again, like, there must be something happening. I said the easiest example right here was just to ping this. Look in here. What's cool about this is the destination address. I've config is my address. So when I look at my Snort log, if that rule hit, I should see traffic going from here to here. Now let's look. See, from my machine to that machine. And we saw before how I told before, like, this address is a private address on my VMware. I know it's a private address because it says 172.16. And it's going to this address. And it's that simple. It's that simple. And so what we're going to get into, and I'm kind of so I've been trying to balance this, and I'm like, keep it 100. Like, there's a couple different ways that you can, to get to where we need to get, you probably need to do an operate. You probably need to have an operating system like a Linux or to be able to. I'm running VMware Fusion. It costs a little bit of money for that. There's also, if you're running Windows, you can actually get VMware Player and you can use some virtual machines. There's also VirtualBox that's free that you can use. But if you really wanna be at get to a good level that I want to get you at, I think you probably need to install. You probably need Wireshark, and you probably need to do Snort. So what I'm going to do is I'm gonna go in my bag this weekend. Last weekend I was doing a lot of planning that you haven't seen yet. You'll see it coming up. I got some stuff that I'm planning, and I think that it's gonna help out a lot of y'all. So I'm actually working on a solid curriculum to try to start delivering to y'all next week. I'm working on this. I'm working on getting some Snort labs to y'all. I'm working on getting some Wireshark labs to y'all. I'm thinking we might do a little bit of exploitation. Might look at some of the different exploitation toolkits. I just want to demystify stuff for y'all. I think that people think this stuff is hard, and it may seem crazy right now, but put in the work. Put in y'all work, and I'm gonna be putting in my work on this side in order to get y'all good content, and I want to help y'all out big time, and so having said that, let's look. I'm gonna end a little bit early tonight, and what I'm gonna do is I'm gonna do like y'all can ask me questions. I don't want to get too confused. I don't want to get too crazy. So it's not working. All right, so where are we at? We at 1.6 now? All right. Just did 1.6. All right. So remember what I told y'all, these 802 dot whatever standards? I'm going to blow this up. All right, these standards right here, these frequencies, it says they're network topologies and configurations. Hey, remember what I said? Everything on here is related to some kind of physical thing or radio wave, right? So some of these standards is either physical or radio related. Here's frequencies. That's radio. It's talking about physical limitations. It's talking about distance and how long does it take to cover that distance or whatnot. Or my bad, it's not. It's this speed is talking about how much kind of like bandwidth you have, as far as like capable of that thing, of that physical medium transmitting. So some things like fiber optics is super fast. Some of bandwidth, all this. Know these definitions, but most of these things, even a site survey is referring to a physical thing. So all this stuff right here is physical layer of the OSI model. Let's go down here. All right. So SAS, PASS, all that stuff. So 1.7, 1.8. These are kind of important to know. We can actually go over this. We'll go over this next week. What's crazy though, and I already showed y'all some of this stuff in Wireshark. We'll talk about DHCP service and all that. This is light homework. 1.7 and 1.8 is homework. VirtualBox is free. Somebody said that. All right, I'm gonna take questions for a couple minutes, and then I'm gonna bounce. Ask me any AMA. What's good? Yes, 1.7 and 1.8 do the terms. Give me an example of the first question. Sunrise Cloud. The first thing I'll do is software as a service. Software as a service is there's a couple examples. Software as a service is something that you usually pay a subscription to. That subscription would be something like a Salesforce. They invented the term. Salesforce did. You pretty much license software and you use it. It's typically browser based. But many people are doing software as a service. Like if you use Adobe or many of these other products, they're going to more of a cloud model, a SaaS model. Software as a service. It means you really don't own the software; you're just licensing it. It's somebody else hosting it. There'll be a lot of crossover to CEH. So if you understand some of the stuff I'm putting down here, you'll definitely be good. Office 365 definitely is SaaS. Google Suite, great example of SaaS. Nmap, Wireshark, Snort. Yep, those are the ones you should try to download and get to know. VirtualBox free. VirtualBox is free. I believe VMware Player is free. I mean, somebody tell me? I haven't used VMware Player in a while, but it's free and you can use it. I think. Yeah, VMware Player is legit, man. I don't know why people don't use it. I'm just looking to see if this is free still. I think it's free. I may be crazy. VirtualBox is okay too. You can't make your own VMs. Is that true? I don't know, but you can't make your own VMs?
I'm not sure.
Siri said they're not sure. No, I think you can. VMware Player is good. I've definitely thought I created some stuff on VMware Player. I think VMware Player. The limitations are you can't save snapshots or some crazy stuff like that. But VirtualBox is another option. The things that we're going to go over here is Snort. Try to install Snort. Snort was a pain in the butt for me, by the way, too. So we're gonna try to help y'all get to it. So if be in the channel on Discord, and we'll try to get you guys running. If y'all having problems, VirtualBox is free. Somebody asked me what a specific thing was. What is it? Where? Let me look. 1.4. Dang, I don't even know that. Hold on a second here. Somebody asked me what this term was. My bad. Okay, it's IP version 6. That's what it is. Alright. So basically, it's talking about IP version 6. Somebody gave a great explanation of this. But yeah. You know what's funny? I've been doing networking and security forever, and like IP version 6 adoption has been slow as I don't know what. I'll be surprised in 20 years if everybody's running that. Like, maybe it gets to a point where it's like abstracted and everybody's running it. It's kind of weird. But yeah. Hey, man, I appreciate all the freaking participation in that chat, man. This is freaking amazing. Yeah, IP version 6 is supposed to be in the future for a long time ago. I mean, it's been like forever. I'm telling y'all, I've been since I started 20 some years ago. Since I started, people was talking about IP version 6, and it haven't happened yet. Yeah, someday maybe. I mean, we get more and more stuff on the internet, right? Somebody want to do subnets? We can do subnets. I'll make sure I cover that because that's definitely a hard topic, and I think I can explain it pretty well. The transition has been slow because network address translation and the proliferation of private networks. When I first started, the DoD, all these big schools, they own Class A address spaces, and now everybody's throwing those back into the pool. We were running out of them, but now everybody does. Everybody does NAT, network address translation, meaning that you can use 10 space, 192 space, and 172.16 space, and you don't really need them no more, right? So all the IP addresses that there was this big problem, people don't even need them no more. Yep, you can capture your own PCAP files on your network. That's good advice. So do some packet captures yourself. Um, you know what's like super funny? Like even like some of these tools that you hear about that sound so amazing, like the FBI has. You know, they say FBI this and all these different agencies this, and they're sniffing these packets and all this, and it's sophisticated. All this stuff is like basic as a mug, bro. Like everything you you see on TV, even like the sophisticated hacker attacks, it's all freaking easy, man. Like none of this stuff's hard. It's all the same stuff. Learn stuff for the test. Somebody saying, should they learn IP version 6? Learn how to answer the test questions if you're taking the test. For sure. You may see it every once in a while, but you know, IP version 6 is not going nowhere. I mean, IP version 4 is not going nowhere. Discord. Hey, can somebody put the Discord? Discord is a community growing there. People are helping each other out, talking, asking questions. Right. I see sometimes somebody saying, "Is it popular for phones?" I guess. I mean, it's abstract at this point, and it doesn't even matter no more. So, I know foreign countries at some point, like a lot of foreign countries, like I'm from the U.S. of course, a lot of foreign countries couldn't get IP address space because all the U.S. hogged it up, so they jumped on IP version 6. But I really don't think it matters that much. And we can do some captures in IP version 6. It's the same stuff, man. It's the same stuff. TCP IP still there. I mean the whole, TCP's there, UDP, all the protocols, all that stuff's still there for the most part. It's not really different. You never done any coding? Something you need to learn? I think coding is good to learn because with coding you can automate stuff. And some of the stuff we even talked about here, like today I spent like freaking hours getting Snort to run, and it's still not running the way I wanted to. It's still jacked up a little bit, so I couldn't show you a lot of stuff. But what I'm gonna do is probably write a script to just freaking do it automatically by itself. So coding is awesome. Coding allows you to automate stuff. I love coding. Yeah. So somebody said, "Are you? Am I sure you have worked? I am sure you worked in a SOC. Each SOC uses different tools that may do the same thing. How do you adapt the different vendor tools? For one example, SOC may use Cisco Umbrella, and next day they change to something. So here's the deal. Know the basics. Know how the basics really work, right? And that's what I tell people. This example was they're using Cisco Umbrella. and then they're using it. Most of the time, you just have to understand how the UI. It's just basically UI stuff, right? And if you know how this stuff works, like if you know how IPS works, so Snort can do IPS capability where it can shun and shut down instances of attacks when it sees it, and you could do automation, but at the core, it's all the same stuff. They're doing packet inspection. They notice a bit different behavior, and they alert on it. That's what all this stuff does. So that's how it works. And so that's all this works. I want to break this down and like, oh, this is freaking easy, and then you can go learn anything you want to. You can learn any tool. You can do all that stuff. So the tools that they use don't matter. Talk about for security analysts. So all right, yeah. So totally. And so what we do. So this is how I create resumes. This is how I'll show you how this. If I was trying to get a job, I would type in security analyst job. Go to all. All right, go down here. Look at Indeed. Sweet, I got a job. So this is how you do it, right? This is Linode, right? This is the employer. So what do you do right here, right? The analysts are up here. Let's start up here. But I usually start at the bullets, but let's look at this. Orchestrate and execute. Leadership team, blah, blah, blah. All right. You got a mindset and methodology. The mindset being the methodology. Continue to hone your skills. Align security, risk management, and business objectives. All right. Operate with a team that takes responsibility for security monitoring of key technologies. Effective analysis tries security information events. So one of the things you're doing is you're going to be looking at security information and events in here. And so what you can do is you can start messing your resume to match this too. Alerting rules within the SIM. I'm showing you with Snort. This is how. Dang, this is probably tiny. Hold on a second. And plus y'all can't see. I apologize for being stupid. Hold on a second. God dang it, what's going on? My dog's on me now, causing problems. Hold on a second, just hold on. I'm trying to blow this up. So on your resume, what you're gonna look at all this stuff right here. Threat monitoring, log correlation analysis. What you put in your resume in bullets is you understand log management. You understand intrusion detection. Some about cloud security. Traffic analysis. Malware analysis. Digital forensics. We're going to learn many of these things in these next couple of weeks. Right? And that's how you do it. And then you mirror what we're seeing here. Linode is a Linux company, so if I wanted to work there, I know they have a bunch of like cloud stuff. Knowledge of SIM technology. Understand the principles of Trojan security events. Right? This is some of the stuff that we're already talking about here. It says preferred to have security incident response experience, but not essential. If you can go in there and explain some of the stuff that we're going to go over here, you're going to understand how to do this. Strong communication skills, right? It says Bash, Python, Perl. The one I will learn, Bash is Linux, and Python is the one I recommend people to do. Understand the fundamentals of the scripting languages. Easily being able to. But so on your resume, you would have messaging on your resume to match this. I would say I have experience in automating scripting through scripting these things. It would be like exactly what it's saying here, my resume. Let's look at this other one. Analyze information data. Data flow, interconnections, blah, blah, blah. Protect high value assets in an interconnected thing. How do you know what the high value assets are? Well, that's what that whole information assessment methodology is in risk management and understand these things. Requirements. Interpreting federal government directives. So what's crazy though, some of these directives you see here, this risk management framework, these are some of the things you can go download right now. Know these things because these things are actually pretty cool. I would recommend doing a cybersecurity framework because it kind of gets everything into one. So here's the deal. Take the resume, take the job rec and mirror what it's saying for the most part. Some of these are really good. Like that Linode one was good. I would take knowledge of physical security, security awareness, identity, access management, vulnerability management. We're going to be able to use Nmap in order to do some kind of vulnerability scanning. This is in Austin. Just go down to the responsibilities and the key skills and all that stuff. You know what I'm saying? This time about global terrorism, Stratford funny. All right, so pay no attention to the year requirements and all that crap. If you can articulate the stuff that we're talking about here, you're going to be good, right? You're going to be straight. All right. I know I went in for a second. I'll be spazzing out. Hey, I appreciate y'all. What the work-life balance? Well, dang, I'm terrible at work-life balance, so I'm not an expert on that. I don't think degrees matter as much as they used to. Heck, I work from home and and I have a terrible work-life balance. I try. All right, so even if it says a job senior, I would not pay attention to senior. I don't care. Do not care about that stuff. Be able to articulate the things that we're talking about here, and you're gonna be good. I'm telling y'all, you'll be good. You know, you may not start out at a senior pay, but the only reason you would learn these skills is there's no way to fake know and snort. You can fake it, but if you can go in there and articulate how you learned it, I learned it because I built my own lab and I built these rules and I did all this stuff. I know how to analyze PCAPs by this. I use Snort and I use I use Wireshark to do protocol analysis. I looked at honeypot stuff. The story that I'm telling you, that's going to get you a job. You just say, this is what I know. And people are like, holy crap, this person is a self-starter. They'll go learn new stuff if they need to. That's what they're hiring. They're not hiring people that know it all. They're hiring people that, snap, this dude already knows this stuff, or this lady already knows this stuff. And they're going to continue to learn. The self-learners are the ones that make it in life in general. And cybersecurity is so much stuff that this is what I'm trying to tell you. Focus on the core fundamentals and you're going to win. Focus on those and then you can pivot to whatever role that you may enter. I guarantee you learn this stuff that I'm trying to lay down here, and it's going to be applicable someday. So I'll give you a quick example, one more example. I told y'all, maybe told you a little bit about this. I was at a government place, and these government people were building a contractor, a big contractor, was building a system, and every time they tried to put the system online with the government, the system failed. Nothing worked. And I'm like, man, they were like, we don't know why it's not working. And so what I did is I went in and I'm like, let me look at it in Wireshark. In Wireshark, what I saw is I saw some of the requests were plain text requests. And this machine should have been secure. So what happened was the browsers, every time they were rendering these pages, was dropping all the packets that weren't HTTPS. And basically it was doing a request, like, oh boom, all the stuff was being blocked. Now, this was a this was a big government agency and a lot of money on the line. And the contractor spent a lot of money on it. So, only thing I had to do is run Wireshark, look and see, whoa, that's why it's getting dropped. It's doing its protocol and I see it getting dropped. And they went back. Only thing they need to do is change the HTTP to HTTPS and all the code, and it worked like that. It took me 20 minutes in Wireshark to diagnose that problem. And what happened was the dang contractor was going to get kicked off the government, kicked off the contract because they couldn't get it to work. And I used free Wireshark to just diagnose that problem. So the things that I'm giving you, you're going to be able to use it for IT, for system administration, for troubleshooting, stuff like that. Network security. Another thing, you're not going to always have snort on site if you do a response. But if you have a machine and you can do what we call a span on it and capture the network traffic, you can 100% capture that PCAP and run it through your own snort, and you can get stuff like alerts. It'll tell you if it's some kind of alerts if you have your own snort on, and also what you can do is you can go through and analyze the traffic, and do all the things that we talked about. So everything we're talking about is evergreen, and it can 100% use for any job that you want to get. You have to customize your resume to match what they're looking for. When they get your resume, I tell people sometimes do a resume for this person and do a resume for this person. Because what you're matching up with is when they see your resume and you go in and crush it, what you want to do is they're going to be like, man, it's almost like we wrote the rec for this guy. Or we wrote this rec for her because she matches up to everything that we see. You have to have it like that. That's what you do. So PCAP is the network capture, like that we did here. This is a PCAP going through this file, and so what I'm saying, a packet capture, is you go through and you can do your own analysis even when you don't have snort or if you don't have some kind of crazy systems there. And what's crazy, there's enterprise systems that'll have packet captures in them and all that. I see the same stuff all the time. No matter what system it is, no matter if it's CrowdStrike, no matter if it's Palo Alto, no matter if it's Cisco, no matter Carbon Black, no matter if you know the basics, what I'm giving y'all is that you're gonna be able to roll and control anywhere you move. This, my friends, is what I call the laws of gravity. The laws of gravity work no matter what human you are. When you get out of bed, if you don't put your feet down, you're going to hit the floor. Internet protocol is the same no matter where you go. TCP/IP, same wherever you go. All these things are exactly the same no matter where you go. It's no different from me just capturing on my network and analyzing that traffic. Me running a tool like Nmap and analyzing that traffic. Because the attackers are running the same dang thing as you. So what I'm encouraging y'all to do, learn these core fundamentals, and everything is built on top of that. Like, I mean, heck, I'm looking at the thing here. I'm looking at these objectives. All this stuff is physical layer broken out. That's physical layer of the OSI model. Straight up. This right here is layer 2, pretty much, laid out. Because layer 2 is all these standards are like Ethernet related standards. How does the cell phone work? Is it talking this protocol, this protocol, this protocol? That's layer 2. Frequencies is a layer 2 kind of situation too. So I'm telling y'all, like, what they did here is they're taking these things, the OSI model and all these different things, and they're breaking it out, and that's the test. This is like, that's all this is. This is application layer, right here. This is application layer. So anyway, that's all it is. It's just understanding each one of these things. That's it. And if you know this, you're gold. I learned some things 20-some years ago. I'm 45 now. 25 years ago that I still use today. And I still talk about today. And I still use the basic building blocks to figure out any problem. If somebody's talking to me about encryption or how encryption should go, I know how PKI works. I know how private keys work. I know how public keys work. I know how all this stuff works. So I can have that conversation. And that's what I'm encouraging y'all to do. Learn the building blocks of the technology, and it's all the same. No matter if a new flash company comes up, right? And that's it. So what you want to put in your resume is you want to match as much as you can. You want to tailor it to match the particular job. You want to make sure that all those things stand out. And as you work your resume, it's going to incorporate most of the things that people are looking for, right? So you're not going to get into fine-grained detail on here. But if you say I did protocol analysis and blah, 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 Wireshark, intrusion detection, all this other stuff, you don't need all this stuff on there. You just need the stuff that they're saying that you need to know. And you'll be good to go. All right. Hey, I appreciate y'all time. Thanks for showing up again. Part of my job is, some of y'all don't need motivation. But that's that's a side product. I'm gonna give y'all technical information and motivation. So appreciate y'all. See y'all next Tuesday. And I'm working on stuff. And I'm gonna present that to you hopefully Tuesday. Y'all take care, and y'all stay safe out there. We need y'all. We see y'all next week.